Now we study the hyperbolic functions. First we have the hyperbolic cosine, which is called cosh of x, and is equal to e to the x plus e to the negative x, all divided by 2. And the sinh of x, hyperbolic sine, is equal to this. Now you might be wondering, what is the purpose of these definitions? Well, it turns out that in engineering and physics, when you're studying bridges, hanging cables such as chains, ropes, these expressions show up in the solutions. And why do we call them hyperbolic cosine or cosh? It's because when you study the properties of these, they're very close to the cosine and sine properties, with little changes here and there. So here we have the graph of the cosh of x right here. Here's the graph over here. And this is how you enter it into your calculator for the cosh. And right away you can see that there's a point at x equals 0, y equals 1. And you can see that here. The cosh at 0, plug in the 0 here and here. E to the 0 is 1. E to the negative 0 is 1. And 1 plus 1 is 2. Divided by 2 is 1. So that verifies out with the graph. Over here on sinh of 0 is an interesting property. Raise the e to 0 and e to the negative 0, and you get 1 minus 1 divided by 2, and that is equal to 0. So those are similar to the cosine and sine, because the cosine of 0 is 1 and the sine of 0 is 0. So now you get the idea of why they call these quantities cosh and sinh. Hyperbolic cosine, hyperbolic sine. And then what other kind of properties mirror that of the regular trig functions? Well, you have this one, cosh of negative x. And remember, cosine of negative x is the same as cosine of x. So let's see if that occurs here. You plug in the negative x, and sure enough, if you just write that in the reverse order, you get e to the x plus e to the negative x over 2, and that's the same as cosh. So that property checks out, the same as regular trig. Let's see if the sine one works out. Sine of negative x is e to the negative x minus e to the negative x. Again, when you rewrite those and change the order of the subtraction and put a negative out here, you end up with negative sinh x. And that is the same as the sine function of a negative angle. But almost too good to be true, there is the next property here that is a little bit different, and that's this one. Instead of being a plus sign in between cosh squared x and sinh squared x equaling 1, there's a minus sign. That's different than cosine squared plus sine squared equals 1. So there's a little bit different. And if you want to verify that identity, you square the cosh, work out the algebra, you end up with this. Square out the sinh, end up with this algebra. If you subtract them, those quantities, everything cancels out and reduces down to 1. So that's the hyperbolic cosine and sine identity. Tangent, hyperbolic tangent, tang x is equal to sinh over cosh, analogous to what it would be in regular trig. And when you cancel out the 2's, you get this expression here. Then as far as derivatives are concerned, those almost match up, but not quite to regular trig. The cosh derivative is equal to sinh, and these are the steps here that show that. And you're expected to know how to do that on a test. And let's see what sinh is. Sinh prime is cosh, so that is the way it is with regular trig. And if you work out those steps of that differentiation, sure enough you get your cosh. So know those steps for a test. Lastly, the derivative of the tang of x, hyperbolic tangent, is just the way it is in regular trig, secant squared, but it's cosh squared, 1 over cosh squared. And if you differentiate this with the quotient rule, you do simplify out to get 1 over cosh squared x. And there's your hyperbolic identity there. Cosh squared x plus sinh squared x is 1.